this calculation, like this these are all the values. uh, am I audible now? I think. Okay, so through this calculation we get the covariance matrix. Okay, at the last class I discussed about this. Okay, so you will get this sum and you just divided this by this, divided by 9. Why it is 9? 10 minus 1, because there are 10 values. So we'll, n is the number of elements, so 10 is the number of elements, minus 1 is 9. So we'll get a covariance matrix. Okay, so our C will be, C will be, wait, I will write it down. 0.0, sorry, 0.06154 and 0.6154 and 0.7165. Okay, so now we need to first find out, so in order to find the eigenvector, so okay, eigenvector, we need to find out eigenvalue. Okay, so I will not tell, if you are not from mathematics background, please go through this eigenvector and eigenvalue. Okay, it's a part of matrix. Okay, so you just, if you read matrix, then you will get to know about this eigenvector and eigenvalue. Okay, now in here we will just calculate. Okay, so how to calculate this? So in order to calculate the eigenvalue, in order to calculate the eigenvector, we will first have to calculate eigenvalue. Okay, so how to calculate? There is a formula, C minus lambda I, okay, is equal to 0. Here lambda is the eigenvalue. Okay, C is the, we know, covariance matrix, and I, anyone can tell what is I? Okay, I is known as identity matrix. Okay, okay, if we consider 2 cos 2 matrix, what will be the identity matrix? 0 0 1. If we consider 3 cos 3, then similar like this. Okay, so this is the identity matrix. So we have the given the, we have find out the covariance matrix from the equation. So 0.06165, and this one is 0.6154. Okay, minus 0.6154, 0.7165. Okay, and minus lambda 10010. Okay, so we will do the, what we will do? So basically we will do the multiplication. Okay, multiplication. From here you can find out that if we do the multiplication, 6165 minus lambda. So first we have to just multiply with this. Okay, lambda, then minus. Okay, so did you got my point? I am multiplying with this, means this here will be lambda and here will be lambda, just minus this. Okay, so this is lambda, and 0.6154 and 0.7165 minus lambda. Okay, so what we will do, we'll just take the determinant of this. Okay, determinant, we'll find out the determinant. So what to do, just cross multiply this 2. Okay, so we will find out a value like lambda square minus 1.333 lambda plus 0.0630. Okay, you just multiply, okay, both this with these two, okay, then these two value, and calculate this. Okay, you will find a value like this. Okay, you will find the equation like this. So we will get there is a square. So if it is a quadratic equation, okay, so what will be the, so there will be two answer. Okay, so it will be first one we consider as a lambda 1, that the value will be 0.0490, and lambda 2 will be 1.2840. Okay, that we will find out through calculation. Okay, if we consider the first root is lambda 1, the second one is lambda 2, then this is the, these two are the eigenvalue. Okay, so we have to calculate both the eigen vector from these two eigenvalue. Okay, how to find out the eigenvector? So what we will do, see, so this is also formula lambda. So what is this V? So I'll show you what is V. So C is the, you know, covariance matrix. So 0.6165, 0.6154, and 0.61, 0.7165. This V is nothing but, we will denote it as a x1, y1. Okay, what is lambda? For first value you just calculate. Okay, for second value we have to again calculate 0.0490 and x1, y1. Okay, this will give us one eigen vector, and this value will give us one eigenvector. Okay, so for the first eigenvalue we will calculate the eigenvector. Okay, now just multiply this. Okay, so we'll get two equation. So if we multiply this, okay, then this one you have to multiply with this. Okay, then again 0.6154 into y1. Okay, so then again 6154 into x1, then 7165 into y1. So you do the matrix multiplication, we will get two equations, and you multiply this with this. Okay, so basically what will be the answer? 6.165 x1. This you know this right now, matrix multiplication. First row, first column, you just, I think you know this. Okay, I'll not go into details. 6154 y1 is equal to 0.0490 x1, and you just multiply with this one, this one. Okay. Okay, so we'll get two equation from this. We'll get 0.575674. You just calculate. Okay, I'm just putting the values because we have no time to for the calculation. And from this we will get 0.6154 x1 minus 0.06674 y1. Okay, so we will get these two kind of equation. So x1 in related of y1. So first what we need to do, we will find out what is x1. Okay, so how to find out? So just you just divided this by this one, 615 0.6154 will be divided by 5674, then the value will be like this 1.0845 45. Okay, this will be the value. So we need to find out what is x1. Okay, so how to do that? Okay, so first what you will do, so just consider this. Okay, x1, so you will just consider x1 as a 1.0845. okay, this value, and we will first take as a 1. Okay, first y1 we will consider as 1. Okay, then just we will square this thing. Okay, we will square this thing. Okay, basically we are taking this one, and we are taking y1. Let's first, for first value we considering it as a 1. Okay, just have to square. Okay, square and just add both these two. Okay, so basically it is not a matrix, I am just writing it like that. So 1.7614 plus 1, and we will find out the square root of this thing, 2.17614. 2.17164, then we will find out that 1.47517. Okay, so what we will do, you just minus from these two value. Okay, from 1.0845 minus 1.47517, and from here 1 minus 1.47517. Okay, I will directly write the value here. I will not do the calculation, I will directly minus. We will get the value like this, minus 0.7351, and one is 0.6778. Okay, and for x2 we'll again we are considering for the first one. Again for the second one, again we'll get a value like 0.92194 y2. Okay, so again we will calculate 0.92194, we will consider is 1. We'll square this. Okay, we'll square this thing. Actually basically what we are doing, I'll show you. This is 4. Okay, okay, and we are finding out the square root of this 2. Okay, 1.84, 1.3601. Okay, so if you minus this from this, okay, we will get the value like this, 0.6778. okay, 0.7351. okay, similarly you can do it this for this lambda 2 value also. Okay, you will find out another this eigen vector. Okay, so why we need this, I will tell you later. Okay, just go through the this equation. Okay, it will be a bit difficult for you to understand if you are not from the mathematics background. So but I'll make sure in the programming phase you will get it. Okay, so now we will directly go to another thing called confusion matrix. You will find it many times. Okay, so what is confusion matrix? So don't confuse about the confusion matrix. So confusion matrix, for confusion matrix, I will say some term. TN. Did you hear this term ever? TP, FN, FP. Do you know this term? This is called true negative. So I'll explain you also. True positive, false, hence false positive. Okay. So let's say I went for a doctor. I went for a doctor. So I asked him whether I have this disease or not. Okay, let's say I have a box. So if the actual answer is, let's say I have a pox, yes, okay, but the doctor said that I don't have the pox, okay, that is called as false negative. Why? Because he falsely said I don't have the pox, okay, that is false negative. And true positive means if I have pox, okay, doctor said that you have pox, okay, then that is true positive. Okay, let's say I don't have the pox, okay, I don't have the pox, and doctor said that you don't have the pox, so that will be true negative. Okay, let's say I I don't have the pox, okay, but the doctor said that you have the pox. That is called false positive. Did you get my point? Okay, I'll show you. I'll show you. So let's say I will prepare some this kind of matrix. Okay, so I'll tell you what this matrix is. So this is the left column is the actual value. Okay, actual value, and this one is predicted value. So we have a machine learning model. Okay, so we know the actual value of the model that will give, and we have some predicted value predicted by the model. In the last class I have tell you that if I gave you an orange, if I give you one feature that is you have to be it is fair, then the model will tell you that it is a ball. Okay, only one feature is there. Okay, so that is predicted value. Okay, and actual value, it is not a ball. Okay, that is actual value. So for this similarly, so what we will do, so let's us consider about the this doctor example. Okay, yes, okay, so let's say if I don't have pox, and doctor also said that I don't have the pox, so what is that? That is true negative. If all do this both are no, then true negative. Okay, then no yes. Let's say if I don't have the pox but the doctor tells that you have a pox, then it is false positive, FP. Okay, and let's say if I have the pox, okay, if I have the pox, then doctor said that you don't have the pox, so that is he's falsely saying. Okay, so false negative, then true positive. Okay, so if you want to find out, just don't confuse, just if it is both no, then it will be yes t. So first t will come. Okay, no means n is there na, so you just remember tn. In here yes is there, so you can consider as tp. Okay, other two, this is if no is there, yes is there, then it's false positive, and this will be false negative. This one no, okay, that's why it is no. If it is in here, this is yes na, so p. Okay, did you get my point? Do you have any confusion about this matrix? You'll get it many times in this to find out the accuracy or these things of a ML model. It's a very important concept. Okay. So this is the basically the confusion matrix. Okay, so now we'll consider some model. Okay, let's say we have some 165 rows, number of entries, you can say number of entries are there. So in here 50 is the true negative, 10 is the, okay, these are some values, 100. So we will add this to 50 into 10 is 60, 5 into 105. So 55 and 110. Okay, in this type of thing, which one are the errors? So basically false one is the error, na? True is, if true comes before, then don't confuse, that is not error. If f comes, f for fp or fn, then that is a error. So fp means falsely they said that these are positive, but actually I don't have the box, but they are saying that I have the box. So that is called type 1 error. Type 1 error. Okay, let's say I don't have, the box. Okay, sorry, I have the box. Yes, it is yes. So I have the box. Okay, but doctor is saying no, you don't have the box. That is falsely negative. So that is known as type 2 error. Okay, this one is known as type 1 error. If it is false positive, if fn denotes type 2 error. Okay, if it is increased, that if this value increases, that means we have type 2 error. Okay, false negative is, so okay, now we will calculate the this recall value will be there. Okay, so we will find this. So what is this recall value? So recall value is nothing but TP divided by actual yes. Actual yes. Okay, so TP in here just you see. Okay, where is TP? This is TP. So TP value is 100. So true positive is 100. Okay, so what is actual yes? Actual yes, actual yes is this one, 105. Okay, just add this false negative and true positive, and you will get this total actual yes. Okay, so basically I am saying if a doctor said falsely said that you don't have disease but you have the disease, that occurs 5 times. Okay, and true positive means if you have, then you, the doctor is saying you have. So total value will be 100 plus 5, that is 105. That is called actual actual yes. Okay, 105. So what will be the value? 0.95. So this is known as recall value. Okay, so this is recall. So then what is the accuracy? So you have to find out the accuracy of the this ML model. Let us consider this predicting whether you have box or not, that you will take it as a ML model, simple ML model. So we have to find out the accuracy of the model. So how to find out the accuracy of the model? So we'll find out accuracy of the model by this formula. Just remember, you will get this formula anywhere. So to tell. So what is to tell? So TP from here you know this TP is 100. 100. And TN means this. This means how it's correctly predicting the true positive and true negative. Okay. If you don't have the box, okay, no. Sorry, if you don't have the pox, then how it is correctly predicting whether you don't have the pox? So it is 50. True negative means you don't have the pox. So if you have the pox, yes, so true positive. So basically we will just consider true positive and true negative. If it is we are calculating accuracy, just remember first word should be always true, true positive and true negative, then we will calculate accuracy. So how to calculate? TP plus TN. So TP is 100 and true TN here it is given 50. So we'll just add these two, and what is the total sample size? Total sample size is 165. So just divide it by 165. So it will come around like 0.91. Okay, so that is accuracy. So how to calculate the error rate? Can you tell me a simple formula how we'll calculate the accuracy? So one accuracy of a model may be depend on 100%, or we can say in if we say in probability terms, one is the highest probability, or you can multiply it by 100, that is 91%. Okay, but in here we are saying that we have to just subtract it from accuracy. Okay, say 1 minus 0.91, so it will be 0.09. Okay, or you can do this way also, fp plus fn. In here we are considering TP plus TN. In here is just consider false positive and false negative divided by 210. So what are those? FP means 10 plus 5, 15. 10 plus 5, okay, divided by 165. 15 divided by 165, it will be 0.09. Okay, so error can be calculated in both ways. Okay, 1 minus accuracy, if you have the accuracy score, then just subtract it from 1, then you will get the error rate. Okay, error rate. Or you can do fp plus fn divided by 210. Okay, so if it is a you want to calculate the accuracy, then what you have to do? Just divided TP plus TN divided by 210. Okay, if you want to error means false, negatively you think. Okay, negative, so FP false, falsely positive and falsely negative. So divided by 210, FP plus FN divided by 210, that is false negative. Okay, now we have to calculate about the precision. You know that how correctly is predicting these values. Okay, truly positive value we are calculating, we are not care about the negative. If you don't have, then we don't care. Okay, we are just calculating whether you have, yes, true positive. Okay, so we are concerning let's say in cancer, so we will not care about who don't have the cancer, but true positive rate is our main concern. This is the precision score. Okay, so what will be this? Two positive. Two positive means if you have pox. Okay, so let's say you have pox, we will mainly concern about that, because why? In medical terms, you know, if you have pox, then you have to take care. But if you have cancer, if it is for true positive means you have that disease. Okay, so we will have to take care of that person. So true negative we will not care. So in here, that's why we'll consider true positive. So in here, divided by predicted, yes. In this recall, we are taking actual yes. Actual yes means in reality how many people have this actual yes. In here, what we will calculate? The model which predicted whether you have the disease or not, the true value. Okay, so what will be the that? So you hear yes. Okay, so basically false positive we have to also consider, because they are falsely telling that these people have this disease. Okay, so that is we have to take we have to consider, and true positive we will consider anyway. So basically this is the error rate. Okay, you can say this 10. So 100 plus 10 we will add 110, it will be 110. So just divided by TP, we know, I think it is 100 divided by 110. Okay, 0.64. So this is the precision score. Okay, do you have any confusion about the confusion matrix? Just tell me, is there any question regarding confusion matrix? This equation you don't need too much, okay, but this confusion matrix you will need. Okay, if you are doing a, if you are developing a ML model na, then you have to, in a paper you have to always find out the confusion matrix, because this will denote whether you what is the accuracy of your model, that ML model. So is there any question regarding this confusion matrix? Is there any confusion regarding confusion matrix? Okay, I think you don't have. Okay, so now we have a, now we just discuss about this. Now we'll go to another problem. That tell me.
Sir, I'm asking what this in case of precision, TP divided by
Okay.
predicted yes.
Mm.
So this predicted yes, mm, it also comes with the false negative also.
No, no, false negative. No, actually, false positive. Yes, we are saying yes. Okay, in here you just say it is saying yes. Okay, that's why we are considering false positive and uh, true positive also. Okay, I mean, if it is yes, then we are considering. Negative, we will not consider.
Okay, sir.
Did you get my point? So let's say I have 5 patients. Okay, out of 5 patients I will get, let's say three have pox, okay, and 2 don't have the pox. So how will measure the accuracy? Okay, so original value is 3, but our model is predicting 2. Okay, and our, let's say, I'll explain this to you. 5 people are there, 3 are positive. Positive means they have the pox, and 2 are negative, they don't have the pox. Okay, so our model uh, correctly declared that 2 are positive. Okay, and 3 are negative, our model said. Okay, did you got my point? But what will be the actual yes? 3. Did you understand my point? Did you understand my point?
Yeah, yes,
in
sir.
in here 2 plus 1 will be there. Okay, that is actually false positive. That is falsely, it is sorry, it is in case of negative, it is saying negative 3. Okay, so basically negative should be 2, negative should be 2, but it is saying 3. Okay, so basically we are declaring a person as a negative. Okay, falsely negative, the system. Okay, in here we have to also take the falsely positive and true positive. Basically what I am saying, if it is positive na, if it is positive, don't consider on the left side. F T, you just forget. Positive you just take and just add them up. Okay, for actual yes. Okay, and for the similarly for the in here also, just check Tn plus Fp is equal to 60. This is for actual no. Okay, so how many people don't have the disease? 60. If you just concentrate on this this matrix, okay, you will get the point. So if you have further confusion, uh, do you have any confusion now?
So at present, no, but if you give more examples regarding this, then it will be more clear.
Okay, I will try to give some more example. Okay, with some cancer. If I, okay, next in the next class I will show you some ML model. Then I will calculate the confusion matrix from that model. That will clear your point. Okay.
Okay, sir.
Okay. Okay. Go through this thing. Okay. So now I will discuss a topic about this cars of dimensionality. You can say so. So what is cars of dimensionality? So in, I think day before yesterday class we have talked about that overfitting and underfitting problem. Okay, so let's say we have some models. So we have trained some models on the basis of feature. So first model we have trained on the basis of two feature. Second model on the basis of four feature. Third model on the basis of eight. Similarly, M5 like 10,000. Okay, M6. Okay, so in here features are increased. Okay, so what you will actually, in the common mind we will think that if you increase the feature, okay, feature means, let's say, to correctly predicting whether you have a cancer or not. Okay, as we will take consider, and then we will consider, let's say, do we have family history of having cancer. uh, if the number of feature will increase, okay, then we know that the correctly the machine learning algorithm will able to predict whether you have a cancer or not. Actually this is not true. By seeing this we know that this is that if it is have many more feature, then the our algorithm will work better because it is tested on many feature. But it is not always true. Okay, so we'll take the previous example. Okay, so by the book we will think that these have the less, these have the less. We might think this like this. Okay, accuracy will increase in this order. That is our, from, if we see from our just naked eye, then this might, this should happen. Okay, but it is not always. Why? So I'll tell you. Okay, in the previous class we have we I have given you an example of a, to predict whether if a given object is a ball or not. Okay, so what we have seen in that parameter sphere, eatable, play, and diameter. In here we can just consider color red. Okay, diameter just you remove it, will you will get confused. Okay, so in here we will consider a, okay, this object. So this is the orange. Orange is sphere. Okay, sphere. So it will be sphere. Is it eatable? Yes, it is eatable. So we can tell that this is not a ball. So if it is eatable, then we will consider it is not a ball. If it is eatable, then it is not a ball. If it is not eatable, then it's a ball. Okay, so then again we will take one again another ball that is color also red. Okay, this color is red. Okay, how to, okay, just wait. This is a red ball. Okay, okay, so sphere, it is sphere. Eatable, no, it is not eatable. Okay, so whether we can play with this, yes. Okay, and it is red, yes, it is red. Okay, this is a ball. Okay, but if we consider a white ball, okay, let's say our cricket ball, sphere, eatable, and play. Actually, not eatable should be there. Okay, not eatable. Okay, up to this point, it is satisfied. If we consider color, then it will declare it as a not a ball, but it is a ball. It is a white ball. So this feature is useless. Okay, this feature is useless to determine whether a object is ball or not. So this is called useless feature. Okay, this is not required actually. Okay, so this useless feature we have to remove sometimes. Okay, we don't require this amount of feature always. Let's say I will ask your roll number. So if I fit your roll number to a model to determine whether you pass or fail in the exam, will the roll number of you will impact on the result of yours? Okay, I think not, because why? Your roll number does not play any role in your result. So that's why we will sometimes don't consider this feature. So in here you just see 4 5 this kind of feature. Okay, but in a large data set, we have a large data set, let's say we have 1,000 feature. So this will not make our life good, that it will make our life that it will increase our accuracy of the model. It will sometimes, what it will do, it will have some feature that we don't require, like this kind of feature, the color of the ball. Okay, we will not require if it is red or blue or green. We need to declare it is a ball. So for that, which are the necessary feature we require, that we have to determine. So this is called cars of dimensionality. If we increase dimension means feature, okay, number of feature. So if we increase number of feature, then it does not mean that it always get uh, the accuracy of the model will increase. Actually, it has a threshold. In here, let's say 12 is the threshold. Okay, up to 12 feature, we will consider that this model is performing good. Okay, do this model's accuracy score is very good. But if we increase, let's say 1,000 feature, if we do it for 1,000 feature, then the model of accuracy of that model will actually will not increase. Actually, it will go down. Why? Because those are useless feature. So sometimes you see what happens during our exam. Let's say we studied too much. Okay, we studied too much, we got confused. So what to do with this information, what to do in information? So if you have social science in the next day, so whether you will have maths also, you have to if whether you will read maths or not, no, on that day you will concentrate about only social science. Okay, if you study maths along with social science, it will you will get confused the day before the exam. Okay, you have to study, but if you study a day before the exam both the subject, then you might get confused. Okay, similarly for this machine learning models also. Okay, did you get my point? So that's why we will determine what is the number of dimension, or what are the, let's say, threshold value. We'll have to determine a threshold value of feature, and we will have to also remove the useless feature. Okay, that is for a good ML algorithm. Okay, so you got my point, I think. Okay, now let's consider one another question, another thing. Let's say we have to, we have a given data set. Okay, A, B, C, D. Some values are there. I'm just writing is random. Okay, okay. In this data set, this row and this row does not have this data. Okay, it has blank space. Sometimes what happen if you are taking some values, okay, in real life example, by some mistake you don't enter this value, okay, you will not get this value. So how to tackle with this problem? So you can, one way you can tackle this problem is the simple way. Can you tell me the simple way? You are doing it in only real life also. Let's say if in one exam you have some bad examination and you fail some in some subject, okay, so you don't want to take that record to home. So what you will do, you will discard the papers, okay, you will just remove it. So we will not consider these rows at all. Okay, we will consider only these three. Okay, we can do it if it is has many values actually. Okay, you just discard the missing values. Okay, just discard those rows. Okay, just consider, let's say 1,000 rows are there in here. Just I am say giving you only 5 rows. Okay, if it has 1,000 rows, if let's say 10 rows have missing data, okay, just consider 990 rows. Okay, just remove those 10 rows. Okay, we don't need to consider. So there's this one, so that is known as remove the record. Remove the record. Don't consider it. Okay, just remove the record. Okay, that is the first one. Okay, and the second one. Let's say you don't have too much of data. Also, let's say 1,000 data you don't have. Only 10 entries are there. 10 rows are there. So what to do? So you can do one thing. Create a submodel. Create a submodel. Model. Okay, and one you can do is a famous automation strategy. So what is this? So you can just calculate the mean, median, and mode of that this value. Okay, so what is the create a submodel? So first consider this row, these two values are missing. So how to calculate? So we have this ABC, we have ABC, we need to calculate D and E. Okay, how to do that? So just let's say we'll, in between this we will create some kind of a model, and we will try to predict the value of D and E. Let's say D value is 2, E value is 3. From that prediction value we will get 2 3. Or you can do this mean median mode. Okay, median I will tell you. So in here you just see 4 5 6 8. Okay, okay, so you need to predict this one. Okay, how to do the median value? So you just take this. Okay, so what will be the median value? So n is the even number. Okay, so you just take 5 or 6, any of these thing. Okay, you can take 5 or you can 6. Okay, n is 4. 4 plus 1 divided by 4, 5 by 4. So basically 1.5, you can take this 5. So 5. So you just calculate the median. Okay, find out the median. And mode means how many times it is occurring. Let's say it is 6. In here it is 6. So 4 is occurring one time, 5 is occurring one time, 6 is occurring two time, two times. So just replace this as a 6. Okay, these are the some methods that we can fill up our records. Okay, this will be beneficial in this if we develop some mm, machine learning model. Okay, next class I will take it tomorrow. So just be prepared with the laptops. So I will go to the this first ml model. Okay, that is on iris dataset. Okay, dataset, just be prepared. Okay, you can do it in Google Colab. Just read about this iris dataset. Okay, okay, thank you then. So we'll meet again tomorrow. Okay, thank you.